Training your first model with SongExplorer. In this video, I'll demonstrate the workflow used to make the initial annotations to a new set of recordings. To make this easy, sounds are found using simple thresholds in the time and frequency domains. These are then clustered, and a GUI is used to jump directly to the sounds and apply a label. The commentary here will be brief, but much more detail can be found in the written documentation over here. First, click on the Label Sounds wizard. Doing so will highlight just the actions that are necessary in this workflow: detect, train, activations, cluster, and visualize. Generally proceed from left to right. So first we start with detect, and we need a WAV file. The algorithm which detects sounds uses these settings for the thresholds. Once these are all filled in, and the WAV file, the Do It button will be activated and indicated as such by turning red, at which point you can click it and start the detection program. The status is indicated over here. When it's gray, it means it's waiting in the queue. When it's black, it is being actively run. When it turns blue, it has successfully finished. If it turns red, there is an error. The output of the detect script creates a CSV file which has all of the events that have been detected. This is what it looks like. Each row is an event. The first column indicates the WAV file that the event was in. The next column is the start time in sample ticks, and then the stop time. What kind of an event this is. These are all detected events since it's the output of the detect action. And all these at the top have passed the time threshold. Down below are some events, some periods in time, which pass the frequency threshold. And then ambient is simply those which pass neither the time nor the frequency threshold. Next, we want to cluster these sound events and visualize them. First, we need to randomly initialize a network. It's important to make sure that wanted words here is set to time, frequency, and ambient, and label types to detected. If you clicked on the Label Sounds wizard, these things should be automatically filled in properly. We're going to train for 0 steps here because we don't want to actually train a network on these detected events. We simply want a randomly initialized, untrained network. Now we're going to take this randomly initialized untrained network and we're going to do the forward pass through it for all these detected sounds that we have. We need a checkpoint file. Any of these 3 files here that have ckpt-0 in them will work. What the activations button does is to save the input, the hidden layer, and the output layer activations for all of the detected sounds that we just found. It stores them in this activations.npz file right here. in the ground truth directory. Now we want to take just the input layer and cluster them. We have a variety of clustering algorithms. We'll use two-dimensional UMAP for this tutorial. And now we'll visualize. The result is plotted over here in these figure panels. Each of these dots is an event, a sound event that was detected using the thresholds in time and frequency. If we click on one, a circle will be drawn around it, and all the events within that circle will be plotted over here. We can click on one of those, and we can see its context within the recording. We can zoom out, we can pan, and we go back to where we started from. The different colors here represent the different types of sound we detected. Remember, we have those which passed the frequency threshold, those which passed the time threshold, and those which passed neither, about 1,700 in total. We can plot each one separately. What we need to do now is we need to annotate some sounds. So if we click here again, you can see it in context. Zoom out. We can type the label that we want to give to that sound right here. This is Drosophila melanogaster. They have two types of song, sine and pulse. This is a really nice example of a sine song right here. So in the top half, you'll notice, is indicated, let me zoom in here for you. Maybe that's not the best example. Let's go over here. You can see here that this portion in the gray box up here, that portion in time was past the frequency detection threshold. This portion right here was thought to be ambient. And what you can do in the bottom half of the window is just click and drag and lay down an annotation, and we're going to call that guy sine. We can click on another one up here, find a nice another example of sine. And what we're going to do is we're going to keep going until we have roughly 100 annotations across our 3 different word categories. In this case, you can see that this gray box in fuchsia here nicely covers the entire extent that we're interested in. So instead of clicking and dragging across the bottom, you can simply just double-click that gray box, and it'll drop down an annotation below. Now notice here that I made a mistake. I labeled this ambient because I currently have the ambient word label highlighted over here. No worries, you can just click the undo button. It'll go away. Click on sine like it should be, and click back here. Okay, we have 100, a nice round number, about 5 to 10% of the total sounds detected in this file, so just a very small fraction. And now what we're going to do is train a classifier with those annotations. Before I get to that, let me kind of show you where all that data is saved. That's in this annotated timestamp CSV file. As with the detected CSV file, it has the same format. The only thing that's changed is that that fourth column now indicates annotated instead of detected. So now click on the Make Predictions wizard. The action buttons have been updated to indicate which ones are necessary for this workflow, and we're going to train a model. This time for real, instead of just randomly initializing it. Notice that the Make Predictions wizard updated wanted words and label types appropriately, automatically filled those in for you. We'll train for 200 steps. Withhold 40% of our annotations to assess the accuracy on. Now while it's training, you can kind of go check on its progress by looking at this log file. In the beginning are just all the parameters that you've given it. Eventually it tells you the network architecture. So there's going to be two convolutional layers followed by a dense layer. And here's the shape of the weights. And then it also tells you how it breaks down those 100 annotations into the training and the validation sets. And then you can see it does 20 steps as you told it to, and then it computes the confusion matrix on the validation data, and then another 20, and it keeps going all the way to the end. So here you can see nominally everything should be zeros off the diagonal. So pulse, it's making a few errors. We can make some nice graphs of all that data using the accuracy button. So over our 200 steps, you can see here that the loss in green decreased, which is what you would expect, and the accuracy, both the train and the validation, increased to high 90s. Quite good for just 100 annotations. Now we're going to freeze the model so that we can use it to make predictions on a new waveform. And again, I need a checkpoint. This is a new recording, a different recording from the one we annotated, so we can see how well it generalizes. The output of the classify action is to add these new wave files, sine, pulse, ambient, which have probability waveforms for those respective words at each time point in the original wave file recording. And we're going to go look at that now. Here's the original recording. And here are the predictions. You can see some nice pulses here, and they have corresponding peaks in the probability of the pulse output tap. Sine song here, and over here. The sine song channel all goes high and stays high during those portions. And during ambient, you can see the ambient channel goes high, ambient, during the ambient portions. The last thing we need to do is to take those probability waveforms and discretize them to make an ethogram. That is done by taking using thresholds to just make a binary mask. Those threshold files are in the model directory. There's one for each checkpoint. It's simply, for each precision and recall you have in this box over here, when you do quantify the accuracy of your model, it will put in what threshold you need to use for each word to achieve an equal amount of false positives and false negatives on the validation data that you've withheld. So these are all pretty high, 0.99 something. The ethogram button takes that file and as well as the probability files, and simply discretize them to make another CSV file. That's this file here, predicted, with a PR of 1, precision recall ratio of 1, and as with the detected and the annotated CSV files, the format is the same. The only thing that has changed is this fourth column to indicate that these are predicted events. That's it for now. Thanks very much. I hope you enjoy SongExplorer.